So in this example, we want to write this expression as a single log. So we have 7 times log base 2 of u plus 4 times log base 2 of v. So we see that we have 2 logs with the same base, and that's a good thing. If we want to try and put them together, most of the time we need the logs to have the same base. But because we have these coefficients and we have these different arguments, we can't just add them. If this was log base u and that was log base u, then we could add them and get 11 log base 2 of u. But they're different arguments, so we can't do that. So we have to use some of our log properties to try and simplify this. The first thing I'm going to do is I'm going to use the power property, which says I can take these and make them the power of my argument, right? Take the leading factors and make them the power of my argument here. So now that gives me log base 2 of u to the 7th, plus log base 2 of v to the 4th. And we have this other property that tells us if you have the sum of 2 logs that have the same base, we can put the 2 logs together into a single log and take the product of their arguments. That's just the product property of logs. So this becomes log base 2 of u to the 7th, times v to the 4th. And that would be our new simplified version of this log as a single logarithm. In this example, we want to do something similar to what we did in our last example, and we want to take this log and turn it into a single logarithm. So again, we're given 2 logs that have the same base, so we don't have to use change of base theory formula or anything, but we do want to express them as a single log. So just like I said in the last video, usually the first thing that I like to do always is use the power property if I can. So we see that there are no leading coefficients here, but there's a coefficient of this. This 4 can become an exponent on this quantity of x plus 5. So that's what I'm going to do first. So we have log base 4 of the quantity x squared minus 25, and then minus log base 4 of the quantity x plus 5, all of that now to the 4th power. Now, these 2 logs have the same base, and it's a difference of them. So we can actually apply the quotient property, which says we can put them together as a single log with the same base and make them a quotient. The numerator of our quotient is just the first log, so we have x squared minus 25, and the denominator of our log is just the argument of our second log, x plus 5 to the 4th. This can actually be simplified because we know that x squared minus 25, that can factor to be x plus 5 times x minus 5. And we can actually get some canceling to happen. So one of these x plus 5s can cancel with one of them in the denominator. So when we do that, there will only be 3 powers of x plus 5 left in the denominator. So this whole thing ends up simplifying to be log base 4 of the quantity x minus 5, all of this divided by x plus 5 quantity cubed, all of that to the 3rd power. So that is our expanded logarithm combined into a single logarithm.